Hi. In this video, we're going to continue on with from the last video, and this one we're going to do is replace using a list in a stack with using a linked list. Okay, and there's some scenarios out there where this would be better to do, so that's why we're going through this. Now, some of the stuff we've already been through a lot of it. What I'm going to do is I'll show you what we've done, and then what we had to modify a little bit on here. Um, we have our node class here, and there's nothing different with it. This is the same thing that we've had on here on there. So, but then what we did, we would have to do, and I don't want to go through all of this redoing the whole thing. So I'm just going to show you on here. Okay, this is our um, linked list class. Okay, it's the same thing that we've had before. We had the is empty, the add, the size, the search. But when we get down here to the remove, the linked list is removing a specific item. So you have to search through and find the item. In a stack, we just want to remove the first item because we're adding at the beginning. We want to remove from the beginning. So we are doing the last in, last out. So we add a pop method in here that we're going to use for that. Okay, and all the pop is doing is we get the data from the node that the head is pointing to, and then we move the head pointer to be pointing to the next node after the head. So we go around that and remove, so that it's removed from there. The other thing we have to do is add a peak because a peak was not in the linked list. And on the peak, it's the same as the pop. The only difference is we don't remove it. Okay. So we have item equals self.head.get data to get the data, and then we just remove return item. So I could have done this in one line. Could have done return self.head.get data. Okay, either one would have worked on that. Okay, we leave the other ones in here because we may want to use the linked list for something else other than a stack. For example, if you want to do a queue, that might be a little bit different on setting this up. Okay, and the print in there we probably don't need that either, but there may be a time when you might want to print out what's left in the stack. Okay, if it's at the end and there shouldn't be anything there, you want to print out what's remaining in there. So we'll leave those in there. Okay, then the next thing we needed to do, and there's not a whole lot of difference with this. This is the stack for a linked list. Okay, so it's a little bit different because we import our linked list, and then our stack then is to use a linked list rather than a list. But the rest of it is all the same. We still is empty. We're just going to check to see if self.items.is empty. And we're calling that from our linked list over here. We'll set these up side by side here so you can kind of see them a little bit. Okay, so we're calling the self.items.is empty. So it's going to call this one over here, check to see if head is equal to none. Then on our push, self.items.add. So it's calling the add method over here, which is going to add it in at the beginning. The pop, and scroll down on here and get that here for you. Okay, so return self.items.pop, which is going to call this and run it. And then the same thing for the peak. Self.item, we're going to set it up to where we get the data and return that item. And then the last one is the size. And I think that's up here at the top. Yep, there we go. So on the size, we do self.items.size, which calls this and runs through it and counts them all and returns the count. Okay. So let's do an example program here. Oops, I don't want to open. I'm going to do a new. Okay. So we're going to do from linked list stack. We're going to import stack. Okay. We're just going to run through just to test things out here. S is going to be equal to a stack. So we have S is going to be our object of the stack class. Print is S empty. parentheses there. There we go. We're going to do a couple of pushes here. So s dot push, 4 out there. S dot push, 10. We're going to print after 2 pushes what's on top, and that will be our s dot peak. Then we'll push a 12 on there, and we'll do another print here. So after another push, how many in the stack? We'll call size. I'm going to check to see if it's empty. And then we do another push here. And then a couple more, or 3 prints here. Do another push. Then we'll do a pop. So do s dot pop. Another pop. And then we'll print to see what the size is again. Okay, so that's all we'll get. We'll just test all that stuff there. So if our name equals our main, then we run main. Okay, I'll go ahead and get this saved. Linked list and do LL stack test .py, and then we'll run this, and hopefully we don't have too many errors on here. There we go. So is S empty? That is true. Let me pull it over here so we can kind of see it side by side here. So we do 2 pushes here, the 4 and the 10. So after 2 pushes, what's on top? 10, because that was the last one we pushed on there. After another push, how many in the stack? We have 3. That was our 12, so we have 4, 10, and 3 in there. Or 4, 10, and 12. 12 is on top. After another push, how many in the stack was the 3? Check if empty is false because we have 3 in the stack. Another push, then a pop. So we pushed on an 8, then we did a pop, which popped off the 8. Another pop is the 12, which was the one after that. And then we check the size again, we're down to 2. Okay, so everything worked out on that. So to show you how the stack works. So now to show this in a regular program, close off a few things so that we don't need anymore. Remember in an earlier video, we looked at base converter. Okay, and let me open that up. See if we'll do it from this one here. And actually, I want to go back. Okay, let me do it this way. Okay, so this is our base converter, and we had from stack, import stack. And so this is running with a list rather than a linked list. So all I'm going to do is change this up here. So from stack, import stack, I'm going to change it to from linked list stack. I'm going to import stack. Okay. So let me go ahead and get this saved. Okay, only change I made in the whole program. Let's see if this works. Run. And no, it didn't. Let me check and see what because I thought that's what I called it. I can get rid of that one there. I don't need that one. Oh, okay, I see. Base converter. I saved that to the wrong place, is what my problem was on it. And I think, yeah. Okay, so I'm going to do a file, save as to my solution folder. See if this runs now. Enter a decimal number. I'm going to put in a 5. And what is the base? 2. And it comes back with 101. Okay. And enter decimal number. I'm going to put in 10. Put in my base as 16. And it comes back with A. Okay. So it works exactly the same way as it worked when I did it with a list, only we're doing it with a linked list instead. And I'll put in 0 and quit out of there. So that's what I wanted to show you, is that now if you come up with a program that or a scenario that you need to use a stack, but you want to use a linked list with it rather than a list, this is how you would do that. Now, one more thing, we're not going to do this, but just to kind of show you, you could do the same thing with a queue. Okay? The only difference is that you're going to have to modify the linked list a little bit. And I think I closed that off. Because in the linked list, you add to one end and remove from the other. Okay, so you can, on your add, this is adding at the top, at the head, but the pop is also removing from there. So you would have to modify this to do, and modify the search would be an easy way to do it, to search instead of, or let me back up here, change the pop to work like the search to where you want to go down until you find, till your current dot next is equal to none, and then that's the value that you want to remove off of there. And you'd have to use a previous to go along with you on that. So anyway, so that's the way to modify that, to be able to use a queue or a linked list with a queue. Okay, so I hope this helps you out on understanding linked lists better and how they can be applied to using them with problems, such as using it with a stack. Bye.